Welcome to classes on nuclei, and it is a chapter on the physics. And today's class is class number 27, higher secondary second year. It is the continuation of class number 6. Keeping in view of the NEET exam, which is very close and bearing at the door, I will very precisely jump over the different topic on the chapter nuclei, and instantly I am coming to the solution of the problems which appears in the NEET and other competitive exams. So mindedly follow the class. At the very beginnings, today's class I will start with difference between nuclear chemical reaction and nuclear reaction. So, in a nutshell, I will just explain in a very short times, and these are the questions very often asked in a very indirect manner. Often questions and true and false terms. These questions are very often asked. So you must have knowledge on this. Don't skip the differences. Nuclear reaction and chemical reaction. Nuclear reaction is depend on the nucleons, means nucleus and neutron. It is related to the nucleus only, and the dependent on extranuclear electron means it involves the movement of electron, and emissions of particles like alpha, beta, gamma occurs during the spontaneous reactive decay process in the nuclei. But here involvement of loss, gains, and making and breaking of bonds occur in case of chemical reaction. But in third point is energy release is very high of order mega electron volt, but here energy loss is less in comparison to the nuclear reaction. It is order of the kilocalorie per mole. Balance, the nuclear chemical reaction is balanced in terms of both mass and energy, but it is balanced only in terms of mass, and it is not dependent on pressure, temperature, and catalyst. And the chemical reactions are chiefly dependent on the pressure, concentration, catalyst, and many other terms. These are the things just to please go through, nothing else and nothing more details is required to know. Now the next topic is type of the nuclear reaction. It is very important, you should know, but the question will not be directly like what are the types of the reactions, but there are a lot of reaction very often asked in the entrance also in the class exam point of view. So again, with a very short span of time, I am going to complete this topic. And then types of the nuclear reaction. There are two types of nuclear reaction. One is natural nuclear reaction, other is artificial nuclear reaction. Natural nuclear reactions is that type of nuclear reaction which occurs naturally. They have a fixed half-life period, and you know very often that a lots of natural heavy nuclear elements are there which breaks up into the exactly half within a very specific half-life period of time. These are called naturally occurring nuclear reactions, and these are the first type. And second type is artificial nuclear reaction, means the nuclear reactions are made with some bombardment or when it is hit with some projectiles, and the new reaction occurs and nucleus splits up into two or more parts with the release of some particles. This type of the reactions which are made by the men are called the artificial nuclear reaction. Artificial nuclear reactions are of different types: projectile capture reactions, particle reactions, spallation reactions, fusion reactions, and fission reactions. Where artificial reactions are the projectile capture reaction, means when uranium-238, here you mind that it is not radioactive. The percentage is very more in the universe, but the percentage of the uranium-235, which is the fissile one, which very easily undergo nuclear fission reactions to give energy of order of that 7.7% is uranium-235. This is very radioactive, but uranium-239 is not generally radioactive. All the other percentages are of 239, but it is sometimes made radioactive with alpha emission and beta emission. I will later on in breeder type of reaction I will explain this mechanism. But in the due course of discussion, I am telling that the nuclear the uranium 298 to 38 is one isotope which is not radioactive at all. So when it is made to bombard with the projectiles and neutrons, the answer will become 92. You know, neutron is 0 and 1 equal to 92 neutron, that is gamma. Am I right? Another is particle reactions, and two particles are reacted when sodium 11 is made to react with alpha. So what's happened? It emits out proton. So to make it balance, 11 and 2 23, 12 and 1 23, 12 atomic mass equal to carbon, and 14 to 27 is 1. This must be 6. It is known to you. This is called particle type of the reaction. Spallation reactions, huge amount of energy is here involved, where copper 620 when is made to react with alpha. Particle twice helium 4 positive and 400 mega electron volt energy is absorbed or given or supplied. We get 17 chlorine, 37 isotopes and 14 proton plus 16 numbers of neutron is evolved out, and that type of reaction is called palladium type of reactions. And fission reaction is means I will separately explain with the more attention with this one, because it is already given in your textbooks, and lot of questions are often asked in your class and also in the entrance exam. So fission reaction types are reactions are where the heavy nuclei are made to react with the neutron, or when the neutron bombarded the heavy nucleus, this heavy nucleus splits up into the lighter nucleus with the emissions of some neutron, 3 neutron per nucleus, and this 3 neutron again will attack. I will say, I will explain later on, and huge amount of energy is released of the order 200 mega electron volt. And nuclear fission, it is the reverse of the nuclear fission. Nuclear fusion means it is fused, means two lighter nuclei will combine all together to give you a bit more heavier with release of energy again, but that amount of energy here is less. When the heavier nuclei is bombarded with neutrons, lighter nuclei of the barium and krypton, like this what I have shown you, I will discuss it later on. It is called the nuclear fission means breaking and splitting, and fusion means combining. When two lighter and this is deuterium and this is tritium, when made to reaction, this is helium with the evolutions of neutron and with 17 mega electron volts energy. These are the some types of the type of the nuclear reactions. So instantly I am coming to the main part of the chapter. So these are the some important differences between the nuclear fission and nuclear fission. Fission means splitting of the heavier nuclei into lighter nuclei, and here the fusion means the combinations of the lighter nuclei to give you heavier nuclei. It's quite different. So there is involvement of the heavier nuclei and there is the involvement of the lighter nuclei. Here heavier nuclei splits into lighter nuclei and lighter nuclei combines to give up a heavy nuclei. Here evolution of energy of high of the order of 200 electron megawatt or more. But here evolution of energy is of the order 3 to 24 mega electron or something more. Nuclear fission is controlled type of the reaction, and nuclear fusion is uncontrolled reaction. And these reactions occurs at ordinary temperature, but nuclear fission occurs of the at temperature of about 10 to the power 8 degrees centigrade. These are the some basic differences which you yourself can understand while you just go through the information. Nothing to explain in details. Again, I have already in my previous class I have mentioned some of the some of the terms in details, and you have also knowledge on this one. One is isotopes. I will not explain once again. I have given in the previous class, and isomers I have given in the previous class. Isotones I have given in the class number 6. Isomers I have given in the class number next. Here I will explain isodiaphers and isosters. Here, these are isodiaphers. 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 So isodiaphers in a very simple way, these are the isotopic mass, isotopic number. A new term you should know. This is nothing minus A minus twice, where A is the mass number and Z is the atomic number, twice of atomic number. So isotopic number, if the two species, two atoms or two elements have the same isotopic numbers, means A minus twice Z, then these two species are called isodiaphers. So you this is A and this is Z. So A minus Z means 235 minus 2 of 292. You find out and find, I think it is, and this is 231 minus twice of 90. You find out both the case isotopic numbers A minus twice, they are the same. Hence, these two species are called isodiapher. The species where A minus twice G number, isotopic numbers are the same, are called isodiaphers. This is new. This is not given in the previous chapter. That's why I am giving in the previous lessons. I am mentioning here. And next, isostars. Isostars actually same atom number and same number of electron. If such things happen, then these are called isostars. Now you say here nitrogen. Here how many nitrogen? How number of atom? Number of atom. Atom number here is 2. Here atom number is equal to 2. The first condition, atom number should be equal to, atom number is equal to 2 and 2. Now second condition is the same number of electrons. Here nitrogen equal to 1, nitrogen 14, electron 2, nitrogen 14, 2 ja, electron is equal to, number of electron is equal to 24. Here 1 carbon is equal to 12, other is equal to 16, 12 and 16, 12 and 16, 12, 16 is equal to, it is 28, this is equal to 20. So number of electron in the both cases same and number of atom in the both the spaces are the same. Hence this nitrogen and cobalt and lot of other things may be given. If you check it out whether number of atoms and number of electrons in the spaces are the same, if they are same, these two spaces are called isostars. So in short, I am given two things. One is isodiaphers and isostars in this lecture. So isotopic traces are the arsenic 74, ionic 31, iodine 131, and phosphorus 32, and isotope 31, cobalt 60, and iron 15. I have chosen some of the important isotopic traces which are very much of have very much of importance in our day-to-day life time. So first one is arsenic 74. Again, these things are the informative. Just you keep it in your mind. You can keep it in your mind. You can answer in very often entrance exam. These things are commonly asked. In arsenic 74, it is used for a test of the tumor in the human body. Test of tumor in the human body is detected with the help of arsenic 74. Iodine 131, it is used for testing the functioning of a thyroid gland, and thyroid which deficiency of which causes goiter disease. Know it very well from biology point of view. Phosphorus 32, it is in agriculture, used in agricultural field as fertilizers, and phosphorus 31 used as medicine, as leukemia is a blood cancer, I think, blood cancer. And cobalt 60 is the cancer used as a therapy, chemotherapy. And iron 59, it is also for detections of anemia in the human body. So these are the some common uses of the isotopic tracers. Again, the term used moderators. Moderators. These things are term moderators. What are moderators? Moderators. Any substance that's the substance which are used to slow down the fast moving electron in the nuclear reaction or nuclear reactors are called moderators. So there are the substances which are used, which are implemented in order to reduce, in order to slow down the speed of the neutron is called moderators. Now what are moderators? The heavy water, graphites or beryllium, etc. Moderator. Now question, why moderator is required and why the speed of the electrons or neutrons are often used? Because in the nuclear fission reaction, you have seen that when uranium-235 is bombarded with the neutrons, then what's happened when it gives baryons and kryptons, am I right? Along with this, we get per nuclei of uranium-235, 3 neutron, fast moving neutron generates. So out of these 3 neutron, 1 neutron again captures or bombards or strike the undecayed uranium-235 left out in the reactions. Again this gives you 3 neutron. Again left out 2 neutron, 1 neutron again react with the other left out or undecayed nuclei to make the reaction to give you another 3 neutron. Left out last one of 3 neutron again target this undecayed uranium-235, again gives us 0, 3 neutron. In this way, the neutron comes out from one single nuclei, 3 neutron, give rise to another 3 reaction, another 3 reaction, another 3 reaction, another 3 reaction. It goes on without an intervention of human being. It is uncontrolled reaction. So the scientists see that what's happened if these neutrons in this way occurs and this self way the reaction proceeds with chain type of the reaction. So it is uncontrolled way energy is evolved after 200 megaelectron, huge amount of energy. So they think that if some way or this way or that way we can slow down the neutron and under their control, under the control of the human beings, and these fast moving neutrons are slowed down. This with huge kinetic energy that moves out. So if you can slow down of energy of order of this electron down 0.05 order, we can utilize we can control the reactions, and with the help of this controlled reactions we can find out the energy, we can evolve out energy can be utilized in generation of electricity in other purpose. Huge amount of energy can be obtained if these fast moving neutrons can be slowed down and of energy slowed down up to this amount of this slowed down energy may be utilized in a controlled manner to make the reaction. So uncontrolled reaction may be controlled. That's why with the help of moderator, the aim of moderator is to slow down this fast moving neutron in order to make the reaction control to utilize the huge amount of energy evolved of the reactions in a very beneficial manner. That's why it is seen that the substances like heavy water, graphite, beryllium, etc. may be used during the reactions, and if these things are placed over this neutron, this neutron again pass through this one. Whenever they pass, they slow down, and again with the ultimate good motto in aim, we can just proceed to generate reaction in a controlled manner, proceed the reaction in a controlled manner to utilize the energy in a very beneficial way. Am I right? So this is the functions of moderator. Now, what is the uses of moderator? Uses, first use is to slow down. Chiefly, we will just discuss of 2 uses of the moderator, water, or graphite, or beryllium, etc. What are the uses? We apply or use these substances only to slow down the fast moving, slow down the speed of the fast moving electron to make the reaction control, and this excess electron from the reaction. So electrons is generated in multiples 3 multiplying. Am I right? So 3 gives 3, 3 gives 3, 3 gives 3. In this way it is multiplying. So if the excess electrons are being controlled or being consumed, being released, being reduced, am I right? By way of absorption. So this moderator can act in a two way. One way it can slow down the speed of the fast moving electron. Another way, the excess of electron is generating inside the nucleus uncontrolled manner may be absorbed, may be lessened, may be reduced by the way of absorption. At the very beginning, at the some part of my lecture, I told you that uranium 230 is 238, though the percentage of this isotope is much in nature, yet it is not too much reactive. It is very unreactive. It is not reactive as like of 235 isotopes. So what's happened? What is the breeder reaction? Just I am giving a very small concept, because if you know, then you can answer any type of question if it is asked. So please don't skip the part or the topic which is already mentioned in the textbook. The breeder reactor, that is this reactor, it is in the less reactive or unreactive radioactive species or nucleus are made to more fissile means more reactive species by species or materials. This is the main aim or objectives of breeder reaction. So I am taking one example so that giving the mass expansion or spending much time on it. Uranium 235, 238 is less reactive in nature, is not reactive, is made to react or bombarded with the neutrons. When it is bombarded, the neutrons means 92, and here is 0. The atomic number will remain uranium. So there is 1, 238 will become 239. Against you are getting uranium 239. It is unstable. So we have decayed one beta particle from it. One question left. I will explain it a bit later. One beta. What is beta? What is beta? Beta. What is beta? Newton. The representation of Newton is this. The representation of beta minus is equal to -1 E naught. The beta B plus, if it is positron, then it is positron. Sometimes it is called positron. It is 1 E naught. If it is a deuterium represented as 2. If it is tritium, it is represented 3. If it is proton, P, it is designated as this. If it is alpha particle, it is designated as twice helium. 4. If it is gamma, it is chargeless. So this is the some representation. We need to know this one. Neutron is represented. This is atomic number, and this is mass number. -0 and 1 mass number 1 0. If it is beta, B negative, -1 E naught 0. If it is positron, B positive, +1 E naught 0. If it is deuterium, 1H2, tritium, 1H3, it is known to you. If it is proton, 1H1, it is known to you. Alpha particle, 2H helium, it is known to you. So what's happened? Sometime in the question, very often a question asks that the beta particles evolves out from the nucleus. Answer is from the nucleus. Very often asked in the entrance. Originated from the nucleus. How will you prove it? Because you see, this is neutron, this is neutron, this is neutron. A neutron outside the nucleus is unstable. Neutron inside the nucleus by the exchange energy is the stable. But neutron as a whole, as an individual, where outside the nucleus is unstable. So it transforms into, in this 1 1 equal to 0, 1 minus 1 equal to 0, 1 plus 1 equal to 1. It is balanced up and below. Atomic number and mass number both are balanced. So neutron changes into proton and beta particle. So beta particle is not coming from neutron. Neutron, where it resides? Neutron is a part of nucleon. It is a part of nucleon. Nucleon, where it resides? It is in the nucleus. So the origin of beta particle is from, in the entrance exam marks, is from neutron, is from nucleon, is from nucleus. Mind that. You can't imagine if you don't know the transformation or change or exchange of neutron when neutron is outside the nucleus. Am I right? So by the way, I have explained one of the important questions very often asked in the entrance exam. So these things you please keep it in your mind, because I later on in the later part of my class I will going to solve out lots of the entrance exam question for keeping in view with the NEET exam very close. I will going to please be follow my class minutely. So beta reactors, I have taken the uranium 238 plus I have bombarded with neutron. So this neutron will become unstable 239 and mass number will remain atomic number will remain the same. If I lose beta particle, what is beta particle? Beta particle means minus 1 E naught. So when losing one beta means you are losing is minus, taking minus. So 2 minus is giving you the minus minus plus. Losing one beta means you are adding up one atomic number. So 92 has become 93, and here E naught and beta particle equal to E naught means mass number will remain the same, mass number will remain the same, and it has become this way. Again, and now in 93 is the Neptunium, you know Neptunium, you know it, Neptunium. Again, if you lose out another beta particle, what's when beta is minus 1, E naught minus 1, minus 1 and minus become plus 1, 93 becomes 94, it is plutonium. So again, E naught equal to 0, there is no change, equal to 39. It is very, very reactive now. So see, fissile materials non-reactive, say in atom bombs and nuclear bombs, we can use this one. So unstable things can be converted into the unreactive, not radioactive substance may be made to radioactive or fissile materials with the help of the breeder reactions. At the time, another question very often asked in the entrance exam is that in atom bomb, what things is happen? Atom bomb is a fusion type of reaction. Fission, break, splitting of the Haber. And what is hydrogen bomb? What is principle of hydrogen bomb? Principle of hydrogen bomb is the fusion, combination of the lighter. So naturally, the atomic energy evolves out in the fission. In the fission is more that in atom bomb gives out huge amount of energy, and the hydrogen bomb, the link with the fission means less amount of energy is evolved in the hydrogen bomb. Now in this part, in the second part is very exciting. You minutely follow each and every question. I will explain and solve out. I will show how the answer is very easy to find out. Before starting this one, I will just write a very simple 2 or 4 or 5 number of the formulae with the help of which we will solve out each and every one of the question which very often asked in the CBSE, PMT and NEET and other competitive exam, and this type of question will surely appear in the next coming NEET and other exam. So minutely follow my class. These are some important formula with the help of which I will solve out a lot of questions answer basing upon this one, not more than this one. Just once again I am repeating the formula of half-life period equal to 0.693 by lambda. It is very often each and everybody of you know, but another type of the question is a part in the derivation. When I derived this one, I have written T half is equal to ln 2 by 2. It came in the exam, in the NEET exam. I will show you why T half equal to 0.63 by lambda 2. Again T half may be written as ln 2 by 2. Why? Because ln 2 is equal to 2.303 log 2 divided by lambda. Again 2.303 log 2 is equal to 0.3010 equal to lambda, and 2.3010 and 0.30, if you multiply these two, you are getting 693 by lambda. So ln 2 is equal to 2.303 log 2 and log 2 equal to 0.3010. If you multiply these two, you will get 693. So this may be written as this one. This point very often comes. Another, the fraction of the amount of substance nuclei remain undecayed. Very often question comes, very interesting one, very often. N is equal to not have to do by n, where n is equal to number of the half-life. How many half-life will be there in the total number? So total, how will you find out n? N is equal to total time divided by half-life period supplied to you. So total time about T half is below. So you are getting n is equal to T by T half. That is T is equal to n into T half. So total time, sometimes in the exam, total time is asked to find out. Sometimes in the exam, amount left in the reaction is asked, you apply this reaction. Sometimes total time to calculate, you apply this formula along with apply total time T equal to find out n into T lambda. Again R is equal to lambda, and this is the formula of activity equation appears in the activity point, and I have not discussed the topic activity. I will explain why. I will solve out the questions answer. Another is n is equal to n naught e to the lambda 2. Next one is one atomic mass unit equal to 9.31 mega electron volt, and electrical to equal to mc square, c equal to velocity of the light, and the volume equal to very beginning I tell you density of the nuclei. So 4 by 3 pi r cube is proportional to the mass number a, and from this I took this one and find out the relation. R is equal to r naught means radius equal to r naught a to the power 1/3, and this is a point from each and every exam. The question comes from this one. So I am efficing out the formulae, and now let me start with the new question asked in the entrance exam. So the question is very simple. I will read out very fast manner. You see, very simple question, nothing to think about it. A question appears, all questions appear CBSE, PMT and NEET. I have taken all the questions for your understanding. So atomic weight of boron is this much. Has two isotopes, boron 11 and boron 10, and you are asked to find out the ratio of boron this and that. So this is the weight. We are concerned with the weight, mass of the boron, and the two isotope, one mass is this much, other mass is this much. I don't know how much of boron is this isotope and how much of boron has this isotope. Mass number is 11, mass number of 10. So let me assume boron, the percentage of this percentage of boron mass 10 is x%, and boron 11 is equal to 100 minus x%. Am I right? Now where total mass of boron, these two type of isomers have the same mass arisen from this amount of mass. Am I right? So that percentage, that 10 mass boron is x%. So that 10 is equal to x%. So 10x plus 11 mass boron is this mass percent. 11 mass of boron equal to this mass percent, and all this will give back to mass. Mass percentage give you mass. If you solve out, so this is equal to 19 and this is equal to this mark. So the ratio of this and this are 19:81. Very simple, nothing to explain, simple mathematics here applied. You just go through example what I have shown. So very simple question. Once again, you are asked the volume occupied by an atom and the volume occupied by the nucleus. What will be the ratio of the volume occupied by the atom to the volume occupied by the nucleus? The volume occupied by the atom and volume occupied by the radius. You are asked to find out the ratio, and very simple, because the volume of atom is 10 to the power minus 10 meter. We know it, and the radius of an atom, it is volume of an atom is 10 to the minus 10, and radius of atom is 10 to the minus 15. It is known to us. Everybody of us know. So volume of atom is equal to 4 by 3 pi r of atom cube. Am I right? This is one. That volume of radius equal to 4 by 3 pi r of radius equal to this. So on dividing V of atom and V of radius, this will cancel, this will cancel out. Radius of atom and radius of nuclei, radius of nuclei is equal to this much. So what is this is actually radius of atom. Radius of atom is this, and radius of nuclei is this. So radius of atom is 10 to the minus 10. It is very simple mathematics. It need not to be done. I think you yourself can do. Nothing is required to explain. If you know volume, radius of atom is this much, radius of nuclei is this much, you just put up one above another below to the power cube and you go on solving. You are asked, you are given mass of helium is equal to 4, mass of sulfur equal to 30 times. You are asked what times mass of helium is, nucleus of helium is the nucleus of sulfur. So we know it is known to us at the very beginning. I gave you the sum formula, and out of this I told you R is equal to R naught at the bar. A is equal to mass number and R is the radius, it is constant. Am I right? So if you asked is, if I told it is helium, so R of helium is equal to R naught. What is mass of helium is equal to 4 1/3. This is one. Now for the second case, R of sulfur is equal to R naught. The mass of sulfur is 32 1/3, it is 2. So R of helium divided by R of sulfur is equal to these two will cancel out. So we'll get 4 by 32 1/3 and very simple. We get R of helium, this is equal to half the radius of helium equal to half of radius of sulfur. I told you this formula is very important at the very beginning, and mind that a lot of questions are being asked in the NEET and other types of competitive exam. By video this, I will solve out each and every one, and I think nothing to record to explain, just I have shown you the way to solve out. So again, this is very simple question. Nuclei of a mass of nucleus of a mass 189 has been split into two nuclei with mass number 125 and 64. An element of mass this much has been split with the two element of mass number this and this. And you are asked to find out the ratio of the nuclei of the two one. So ratio of the nuclei of these two months equal to 125 divided by 64 using the above formula. Very easily we can done it. Am I right? So answer is very simple. Very simple. Nothing to explain. You have to apply the earlier formula. The question is again simple. You see, radius of germanium nuclide is found to be twice the barium 9. What is the nuclei of germanium? So we know R is equal to R naught a to the power 1/3. This is mass number, this is radii. So if you assume it is germanium, what is mass number? Very simple, you can just write radius of germanium equal to R naught. A to the power germanium 1/3 and radius of beryllium equal to radius R naught into A to the barium equal to 1/3. So if you divide all these two, you will get radius of germanium divided by radius of beryllium is equal to these two. Will cancel out, will get A of germanium divided by A of beryllium equal to 1/3. Nothing to explain, very simple. Now what's happened? The radius of germanium nuclei is measured to be twice the beryllium, and you are asked to find out the germanium. So germanium, you keep it germanium as germanium because you need to find out germanium. Nuclei is measured to be twice the beryllium, means beryllium is half of germanium. So we will write this is half of germanium, R of germanium, and this is half of germanium. So 2 will go outside and these 2 will cancel out. So am I right? So we are getting here 2 is equal to A of germanium A of beryllium 1/3. Very simple calculation, nothing to explain. But here your mass number of beryllium is given. So A of B is how much? It is equal to 9. So here put it 2 equal to A of germanium divided by A of beryllium is equal to 9. A of beryllium is equal to 9 is equal to 1/3. Am I right? So on solving, A of G is equal to 2 root 2. It's very simple. Better you do one thing here, you make it 2 cube. Am I right? And this will be on cubing both sides, we will get AJE by 9. So A of GE is equal to 9 into 2 cube. Am I right? This is the answer. This is very simple question asking NEET 20. Very simple question, but one point is that each and everyone may be confused to get. You make it SI form, SI unit, make it kg. And what is energy? Energy is equal to mc square. What is m is equal to 0.5 into 10 to the power minus 3, and c is equal to 3 into 10 to the power 8 meter per second square equal to this. You will find equal to 4.5 into 10 to the power minus 13. Very simple. Dot up. Just you don't forget to convert it in SI unit, because here the speed of the light is equal to, when you will apply 3 into 10 to the power 8 meter per second, it is in SI unit, so unit should be equal. If you don't keep it, if you convert it into kg, your answer will be wrong. That's why a very small and very tricky question has been asked in the NEET exam. Again, this is very simple question from same formula. So R is equal to 1/3. So the radii of aluminium, this is given, and you are asked to find the nuclear radii of the copper. So radii of copper equal to and radii of aluminium is equal to now if you compare radii of copper, radii of aluminium is equal to A of copper, A of aluminium 1/3. Am I right? So you are asked find the nuclear radii of copper. It will remain the same. Radii of copper and radii of aluminium. What is the mass number of copper? It is 64, and aluminium it is 27, and this is equal to 1/3, and this is equal to 4 cube, and this is equal to 3 cube is equal to 1/3. This is equal to 4/3. So what we get here from radii of copper is equal to by radii of aluminium is equal to 4/3. Therefore, radii of copper is equal to radii of aluminum. This is the answer. Again, I think very simple and very easy question. Two very simple question. Already I have told you that X element it is not given, not mass number and atomic number, nothing is given. X is given equal. N and alpha notation is given, and you are asked what is that X. So this type of reaction already I have mentioned in my earlier classes. This is X means this is reactant, this is reactant, X is the reactant. Am I right? That reactant, and what N means here Newton. I have given you the symbol a bit earlier, and the answer is you are given outside the bracket. It is given lithium 37 means it is the answer. It is the product. Am I right? This is the product, and if it is the bombarding particle in the product side, that alpha comes. Alpha, I have given you the formula of alpha. So what we get here is 3 and 2 is equal to 5. So X should be atomic number 5, and what we get here is 7, and that is equal to 11. But here already 1 is there, that should be 10. So you get X is equal to boron this 10. This is the answer. Very simple answer. Nothing to, no place is there to apply your thinking. Now next question, 6C11 5 5 boron 11 plus positron. I told you what is positron. If you recall, I told you +1 E0, mass number +1. So if you just compare the below part, you are asked to find out X, am I right? So here given in back side, below side is 6, that is atomic number 6. Here atomic number is 5. Here atomic number is equal to +1. Here atomic number is equal to, we don't know, we need to find out. Means these two are balanced, means here X, the atomic number is 0. Am I right? Now go to the upper part. This is 11. Here you are getting 11, and here you are getting 1. Sorry, this is 0 positron. Here is 0, and total is equal to both side. Above part mass number 11 equal to 11 0. So you are getting massless and chargeless particle. X is a massless and chargeless particle. It is mass and chargeless particle. Very simple question. Very simple question. So again, this is the second type of the reaction. I have just changed the reaction types. Or you see the T half of a sample of under alpha decay is equal to 1.4 10 to the power 7 second. If the number of the nuclei is equal to 10 into 10 to the power, this the activity is, the formula of activity is equal to 1 by lambda n. What is n? N is equal to given 2 is equal to 10 to the power 21. And what is T half? T half is equal to given 1.4 into 10 to the power 7 second. Am I right? So what is the formula? Activity formula of activity is equal to lambda into n. So we have no scope to use the T half. So what is the lambda? Lambda is equal to 0.693 divided by T half. into n. So if you put the value here, 0.693 divided by t half is equal to 1.4 into 10 to the power second into number of this equal to 2 into 2 to the power 1. So what we get here is equal to becquerel. It is of about 1, 2, 3, 4, 10 to the power 4 approximately. The answer is 9990 becquerel approximately 10 cube. Am I right? Very simple. Just you know the formula, put the value, and the difficulty is that lambda, we don't know that lambda is not given, decay constant is not given. But in place of lambda, if you put the value lambda is equal to 0.693 by t half, then you can use the formula t half just to have placed this one and have done the solution. The question is very important and very often asked in the entrance exams, also in the class test and board and NCERT exam, and minutely follow. If the t half of radium is this, t half of radium is equal to this, you are asked amount left. When the question of amount left comes, I told you use the formula n is equal to n naught half to the power n, where n is equal to total time divided by t half. Am I right? So what does it mean? N by n naught equal to number of the nuclei after some time, it is the initial nuclei, it is the fraction. That fraction is equal to half to the power n. If you just find out this value, this is the amount left. So what we get here is n by n naught is equal to half to the power n. Now what is that n? N is equal to total time. How much time? This is this much. What is the half-life period? This is this. What is n? N is equal to 4. You put the n is equal to 4 and this amount will be left out. It is a very important question and very often comes from now onward. You will get a lot of questions has been asked on this reaction. A formula n is equal to half to the power n. N by n naught is equal to the amount fraction left, and half n is equal to number of time divided by t half. This is another question which was asked in NEET 2021, and again you are given t half is equal to how much? T half is equal to 100 hours. What is n? N is equal to total time. This is 150 hours, and half-life period is equal to this much is the total time. So total time is equal to this, n is equal to this. So n by n naught is equal to half to the power n. What is n? Half to the power 3 by 2. On solving out, you will get the answer is this. Again, it is just reverse of the earlier question. Earlier you are asked what amount will be left after some time, after total time this, if t half is given. Now here what is given? Here t half is given. T half of a sample is equal to this years. What amount will left? That amount will left equal to 25 gram amount will left undecay. After how much time? Means after how much time amount that will left out will be 25, and initial existing amount is 100. Means n naught is equal to 100 and amount left after some time will be 25 gram. And what is that sum time you are asked to find out? After how much of the time the 100 gram will convert to 25 gram if the T half of the system is this much? Means you need to find T. Earlier you need to find N by N naught. The question is very simple once again. N by N naught equal to half to the power N. Am I right? So from this we need to find out N here. What is N? The initial N is equal to 100, and what amount will be left? Initially it is 100, amount to be left out after some time we don't know is 25, and out of this we will find out N. So this is 1 by 4, it is equal to 1 by 2 to the power 2, that is half to the power N. So we are getting N is equal to 2. Now we know N is equal to total time by T half. Now what is total time? Total time N into T half. We have calculated N, so that N is equal to 2. What is T half? T half is equal to 1600, equal to 3200 years after the amount left will be 25 m's. Am I right? So due to shortage of the time, I cannot wind up the class today. Some 4 or 5 questions has been left. I will try to continue this one in the left class, and in my left class again I will start with polymers, which unit has been left in the second year, but it is in the NEET exam. I will give you in 40 minutes. So thanks a lot for watching the class, and please subscribe the class so that you will get the earlier classes, which are conceptual classes, and each and every class are very needful in answering the each type of the NEET or other types of entrance exam. Thanks a lot for watching the class.